The goal in this section is to simplify radicals and combine radicals when we combine like terms. The simplifying radicals is what we're going to start with. So let's take a look at the square root of 72. Now you might look at the square root of 72 and think, well, that's not one of my perfect squares. I don't see it on the left-hand side board. And you're right. But let's think about 72 a different way. Can you give me two numbers that multiply together to give you 72? 8 and 9? All right, good. So let me write that as 9 times 8. Square root of 72 can be thought of as a square root of 9 times the square root of 8. But what's the advantage of this? Well, what can I do with the first one? It's just a 3. Now, sometimes people forget to get rid of the radical. Square root of 9 is 3. We're done with the radical. But let's look at 8. Can we break up 8 in any way? In maybe a similar way? 2 and 4? Good. So that's going to be 3 times 2 times the square root of 2. Or finally, what's the final answer here? 6 square roots of 2. Now, there's a much more efficient way to do this. And it relies on the fact that you have the first 20 perfect squares available to yourself. So let me write those down here. That'd be 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. That's good enough at least for this first example. Let's revisit this one with 72. 72 fits in right here. And what I want to do is I want to work my way up this list and try and find the largest of these perfect squares that goes into 72 evenly. For instance, does 64 go into 72 evenly? I don't think I need a calculator just to figure that one out. How about 49? Does that go into 72 evenly? No. I mean, you can check it. 72 divided by 49 isn't something nice and even. So work your way up. What about 72 divided by 36? Bingo. It goes in twice. So instead of doing it this way, what if we rewrote this as a square root of 36 times the square root of 2? Do you see a nice little savings in our effort here? 6 square roots of 2. Wow, that worked out pretty nice. So when you're simplifying these radicals, I would suggest that you do it the way we did. And that is try and find the largest perfect square that you can that goes into this number evenly. Now just a side note. If you notice, I'm always careful to write the perfect square out in front and then whatever's left behind. You could write it as the square root of 2 times the square root of 36, but here's what happens. People go, oh, 2 times 6 is 12, and they write it there. And that's where you'd be wrong. It's not the square root of 12. You can't multiply this in here. It seems to happen more frequently when people put that number behind. So I suggest you put the perfect square out in front, although, I mean, they are equivalent. So let's try that again with some other problems. Let's look at problem number 16. Nine times the square root of 54. Well, the 9 we'll leave out in front, but the square root of 54, I want to break up. I want to break that up into two parts. Now, one of those numbers that I want to use to help break up that radical is going to come from this list. So 54 is right here. Work your way up the list. What's the largest perfect square that goes into 54 evenly? 9. It's 9 times 6. And you can take your calculator out and do these things if you need to. It's not a big deal. But in breaking it up as 9 times 6, I can simplify this a little bit. That's 9 times 3 times the square root of 6, or better yet, 27 times the square root of 6. All right, what if you did square root of 27 times the square root of 2? What's the square root of 27? Oh, but it's not a cube root. It's a square root. So what's the square root of 27? I don't know. Yeah. It's 5 something. I know that. But what exactly it is, I don't know. So you can break it up like this, but then that's as far as you can go. We can't really go any further. It's kind of a dead end. So what you want to use is a number from that list of perfect squares. Jamie? Mm-hmm. Well, what's the square root of 9? Yeah, so the 9 out in front stayed the same. So there's the 9. And I just took the square root of 9. Square root of 9 is 3. Okay. So that's the importance of this number here being a perfect square. This is a step that you should be able to do kind of in your head. Okay, let's try problem number, let's see. Let me take kind of a brief aside for a second. No, we'll just do problem number 58. 9 plus the square root of 45 plus the square root of 20 plus 16. Well, one thing we can do right away would be to add up the like terms here. The 9 and the 16. 9 and 16 give me 25. But let's play around with these other terms. Square root of 45 and the square root of 20. Both of these have perfect squares that divide into them. What perfect square divides 45? What number from that list? 9 goes in there 5 times. So I'll rewrite that as the square root of 9 times the square root of 5. How about the second one? 4 and 5. So again, these first terms here are always perfect squares. You always choose them from that list that I've been putting up on the board. We can go a little bit further. This is going to be 25. Jamie, can you help me simplify this one? What would that be? Yeah, plus 3 times the square root of 5. Good. Plus 2 square roots of 5. Do you think that's where we should stop? Ah, perfect. There's like terms. So these are your like terms. So that's going to give me 25 plus 5 square roots of 5. All you're doing is you're adding up the coefficients here. You're not going to add what's under the radical. You're going to add what's outside the radical. Yay. Let's do one last one like that, then we'll call it a day. Square root of 20 plus square root of 125 minus the square root of 80. Now the square root of 20 we just did. That's 4 and 5. And I'll do one of these. I'll let you choose which one. All right, I'll do 80. So 80 is 16 times 5. So with 125, look for a perfect square. 4, 9, 16, 25, 36, 49, 64, 81, 100, 121. Look for a perfect square that evenly divides that number. Work your way up. And in this case, you have to go a fair ways up before you're going to find it, but you will find it. Mark, what perfect square did you get? Good. 25 times 5 is 125. Let's simplify that. How does that simplify? Perfect. Now all of these are like terms. So you don't have to show this work. In fact, I'd be quite comfortable not seeing it. But what I'm going to do is I'm going to factor out the square root of 5. If you distribute it, you get exactly what we have here. But the reason for that is because I want to make it clear what we're going to do. We're going to just simply combine the coefficients here. 2 plus 5 is 7, minus 4 is 3. So those 3 square roots of 5. And that's it. What I'm concerned about, what I don't want you to do is I don't want you to add these and get like the square root of 10 or square root of 15. You're just going to combine the coefficients. But that's all we got for number 60. All right, it's a good place to stop here. So let me give you a few problems for homework. We're not going to give all the homework because we haven't covered it. So for homework, try 13 and 15. And let's see, 21 and 23. 29 and 53 through 53, 57, 53, 57 through 59 really. So, wow, 2, 4, 6, 8 problems. Woohoo! All right. So one last time, repeat, stole lot. All right. Have a good one. See ya.